In section 10.2, we're going to learn about the law of sines. Section 10.1, we learned about the law of cosines, but sometimes the law of cosines will not be enough to solve for all of the triangles, oblique triangles that we need to solve for. So section 10.2, we're learning about the law of sines. In this section, we're going to solve oblique triangles by using the law of sines, and we're going to use area formulas to find the areas of triangles. So the law of cosines is used to solve triangles. We know when side angle side or side side information is given. Sometimes other information is given, and in those cases, the law of cosines might not be sufficient. So then we have the law of sines, which may help us out. And we're going to learn about the specific cases that law of sines helps us with in just a minute. But for now, the law of sines is described here. And it's basically a ratio. A, and A representing the length of that side opposite angle A, is to sine A, as B is to sine B, as C is to sine C. So there we have the law of sines. The law of sines can be used to solve triangles when two angles and one side are known, and that's the angle side scenario, and then also when two sides and the angle opposite one of them are known, which is the side angle case. Now the side angle case, this case, is also known as the ambiguous case. It's not quite as clear-cut as the other cases that we've talked about using law of cosines, and then as far as and then as the angle side with the law of sines. And the reason is because angle side angle side, and side and angle side angle, if you're given any of those, there's going to be exactly one triangle that satisfies that data. And we know that because these are actually the triangle congruency theorems that you learned about in geometry. Side angle is not one of those congruency theorems. So that means that there might be one solution, there may be two solutions, or there may be no triangles that satisfy the given data. So we know side angle as the ambiguous case, and we'll talk more about that in some of the examples in a few minutes. So proof for the law of sines, we're going to do this in class, but if you want to go ahead and take a look in your book, it's on page 625, and we'll work on a proof for the law of sines in class. Okay, here's our first example. In this example, I'm going to go ahead and give us a triangle for a visual here. Okay, and what we have is the measure of angle B is 27 degrees. We don't know side B, the length of side B. We know that the measure of angle A is 115 degrees. We do not know the measure of angle C right now, and we know that A is 45. Okay, so given this information, we are trying to solve the triangle, meaning find all of the missing pieces. So that means the missing pieces, we need to find the measure of angle C. Okay, and that's probably the easiest one. The measure of angle C, you know the sum of the interior angles of a triangle is 180 degrees. So you have an angle that's 115 degrees, an angle that is 27 degrees. We subtract those from 180, and we end up with the measure of angle C is 38 degrees. So that's the easiest one. We also need to find B and C. Okay, so let's go ahead and start by working on B. So first of all, we know here, in this case, we are given an angle, another angle, and then a side. We're given angle, side information. So going back to this slide, we know that we have this scenario. It's not the ambiguous case. There's going to be a unique triangle. So that's good. That makes the problem a little easier. And so you want to start with setting up your ratios by choosing a pair that you have an angle and the side opposite. That would make using this a smart choice. Actually, the only choice, the choice that we need to start with if we're going to use the law of sines. So we're going to start by saying, okay, we know that 45 over sine of 115 is going to be equal to, we need to find B, And we know the angle opposite B is 27, so we're going to say sine of 27. So we're just going to solve that ratio and solve B using that, and we end up with B is 22.54. Okay, so we have B, 22.54, and we're going to keep that. And now we're going to find C. So using C, we can use the B being 22.54, but it's probably better to stick with the 45 and the sine of 115 because those are exact values there, whereas the 22.54 we did have to round. So we're going to stick with the 45 over sine of 115 is going to be equal to, this time we're trying to find C, and C is going to be the sine of 38. C over the sine of 38. So then we end up finding out that C is going to be equal to approximately 30.57. Okay, so we're good there. And now we have all the measure of the angles of this triangle, and we have all of the side lengths for this triangle. So we've solved the triangle, and we're good. So let's move on to the next problem. Again, when you're not given a diagram, you want to go ahead and sketch that diagram. So we're going to start out by doing that. You're given a triangle ABC with B, and this should be lowercase b here. A side length of 8, a side length of 5, and an angle measure of 54. And we're trying to find the measure of angle B in this case. So let's start out with the triangle. So let this be B, and this is what we're looking for. This is 5, so this would be C, and this would be 54 degrees. And I know that because the lowercase c and the capital C. And we know that this is 8, and this would be angle A. Okay, now that we have that set up, let's go ahead and look and see what we have here. First of all, we notice that we are given side, angle. Now, given that we have side angle information, let's go back and look at our slide. Side angle, two sides and an angle opposite one of them. So that is the ambiguous case. So we have to see what's going to happen here. Either there's one solution, two solutions, or no solutions. So we're going to start out solving it just like we did the previous example, using the law of sines. We know we're given this 54 and what's opposite, so we're going to use that pair to help us out. So 5 over the sine of 54. And what we're trying to do is find the measure of angle B. So this time we're going to have this, and then the side opposite angle B is going to be our 8. So then our 8 goes here. And when we use this, we're just going to use cross products. So we're going to multiply these two, and we're going to multiply these two. So we get 5 as the sine of B is equal to 8 times the sine of 54. We're solving for B, so the next thing I'm going to do is divide both sides by 5. And I end up with the sine of B is equal to, and I can simplify this. When I simplify this, I get approximately, so I'm changing this to approximately 1.29. Okay, here we know we're going to have to use our inverse sine or arc sine. Or you may not even need to plug this into your calculator, because what we have here is a sine that is greater than 1. And you know by looking at the graph of sine, or you know that your range is restricted between -1 and 1. So in this case, we have no solution, and it's that simple. If you were to plug this into your calculator, you would see an error. Okay, so that's it for example 2. Moving on to example 3, we have an application problem here where we have a lighthouse B that's going to be 3 miles east of lighthouse A. So start out with this lighthouse B. This is lighthouse A. And boat C leaves lighthouse B and sails in a straight line. At the moment, the boat is about 5 miles from the lighthouse. An observer at the lighthouse A notes that the angle determined by the boat, lighthouse A, the vertex, and the lighthouse B is 65 degrees. Approximately how far is the boat from lighthouse A at that moment? Okay, so let's go ahead and finish up our diagram here. So I'm going to make this C, and this is not a right triangle here. Even it's not drawn to scale. So we'll label this as our 65-degree angle that they refer to. This is going to be 3, and this here is going to be 5, and this is B. Okay, so what we're doing is we're looking for approximately how far is the boat from lighthouse A at that moment. So we're looking to find out what B is here. You notice here that we are given side angle information, and so since we're given side angle, just like the last one, that is the ambiguous case. So there may be more than one solution here. There may be no solution, or so 2, 1, or no solutions here. We're going to start out by finding out what the measure of angle C is. So I'm going to say 5 over the sine of 65. And I choose that because I do have that side and the angle opposite it. It's going to be equal to 3 over the sine of C. And so that's going to leave me with the sine of C is going to be equal to 3 sine 65 over 5, telling me that the sine of C is going to be approximately, so let's change that to approximately, 0.54. So C is approximately 32.65. I'm sorry, 68 degrees. And this is the measure of angle C, okay? So we have the measure of this angle here now, okay? And now that we're given that, we can look to find out what the other possibilities are. So from the last chapter, you should remember that if you have when you're using sine to find the other possibility, you're just going to say, when you're in radians, pi minus the angle measure that you get in radians. So in this case, we're in degrees, so we're going to say 180 minus the 68 to find the other angle measure. So let's just give ourselves some more space here. Okay, so we have this scenario here. We have the things that we're needing to find is, or what we're trying to find here is, we have the measure of angle C. So if we're given the measure of angle C in this case, then we could find the other angle, and it is definitely possible. So if you have a 32.68 degree angle, you have a 65 degree angle, it is possible to find an angle B. Now the second case, as I just described, would be to say 180 minus the 32.68 gives us another possibility for the measure of angle C. And that is going to give us that the measure of angle C would be 147.31 degrees. Okay, now so we know this one would work out. It would work out because we could still come up with, you've got a angle A measure at 65 degrees, an angle C measure at 32.68. That means there could be, there is enough room within the 180 for the measure of angle B. Now in this case, you've got the measure of angle C would be 147.31. You've got the measure of angle A already at 65 degrees. If you add those two up, this and this, you already get something that is greater than 180 degrees, not leaving enough room for that third angle, the measure of angle B. So what that means is that this case is not possible, and this ambiguous case, there is only one solution, or one possible triangle that satisfies the conditions that we're given. So we just continue working with the information from here to find out the measure of angle, to find out what B is. Okay, so the measure of angle C we know is 32.68. We know the measure of angle A is 65 degrees. That's going to let us know that the measure of angle B then is going to be 5.47 miles. Okay, and once we have the measure of angle B, then we can use the information that we have here. So we know 5 over the sine of 65, and that's just the exact one that we used in the previous example. Now we have enough information to set up and find out what B is, because we found that angle measure. And the whole reason we were finding the measure of angle B is so that we could set up so that we could set up this equation. So that's sine of, I'm sorry, I put this up here wrong. This is not 5.47 miles. The measure of angle B up here should not be 5.47. This should be 82.32. Sorry about that. So that's going to go down here, the sine of the 82.32. The answer I put up there was the answer that we're looking for, which ends up being that B is approximately 5.47 miles. Okay, and that is the one solution that we have here for that case. So quick review this. Set up your diagram. You notice at that point that it's an ambiguous case. We would like to find the measure of angle, or we would like to find the length of B. Right now we don't have enough information, because if you look at B here, we are not given any information about these two. We don't have the measure of angle B, and we don't have the length of B, which was what we're looking for. So that's what prompts us to go and find the measure of angle B, which is what we did here. Once we find the measure of angle B, then we're able to set up this ratio, this equation here, and once we set up that equation, we can find our one solution. Okay, so that's example 3. Let's move on to another example. Okay, so here we just have a simple triangle here, no application. So we're going to go ahead with our diagram. We're going to have a triangle, and we're going to have this be 6, this is 4.8, so we're given two side lengths, and we're given an angle measure of 28 degrees. So you notice that we have an angle measure and a side opposite it. So again, we have the ambiguous side-side angle case. So again, one possibility, two possibilities, or no solution. So to get started, we in this case we're solving the triangle, which means we need to find the measures of anything that we don't have. And in this case, that is going to be the measure of angle B. We don't have the measure of angle B. We need to find the measure of angle C. And we need to find C. So let's just start by finding the measure of an angle, and we'll say that this is the measure of angle B. We were given A, so there's A, and that makes this C. Okay, so we're going to start out. The first thing we're going to do is find the measure of angle B. So I set up the ratio. We know that we have this pair here is going to be very helpful. So 4.8 over the sine of 28 is going to be equal to 6 over the sine of B. Okay, so now I have that, and I'm just going to solve here. End up with the sine of B is going to be approximately 0.5868, and I'm taking it out to the fourth decimal place when I still need to take the problem further. So I've got the sine of B, meaning that the measure of angle B is approximately 35.93. Okay, so I've got one possibility for the measure of angle B, but I do know that this is an ambiguous case. So one possibility is that it's 35.93. Before I write this down, I should actually check to make sure it could work out. So we've got a 35.93 angle measure. I've got a 28-degree angle measure. So that does leave me enough room for an angle C, which would be 116.07. Again, just using the sum of the interior angles of a triangle is 180 degrees. So if B is 35.93, then C is going to be 116.07 degrees. Okay. Now, from that, I do know that there is another possibility. It could be that the second possibility, since it's an ambiguous case, is going to be that the measure of angle B is equal to 180 minus the 35.93. And if that's the case, then the measure of angle B is going to be 144.07 degrees. Now we've got to figure out whether or not this works. If I have this and I have 180, then I need to look at the measure of angle C. The measure of angle C is going to be 180 minus the 28-degree angle that we already have, the sum of the 28-degree angle we already have, and the 144.07. And if I do that, then I find out that the measure of angle C is going to be about 7.93 degrees. And so it works out. So we have two possibilities this time. So now I know the measure angle B could be this, or it could be 144.07 degrees. And if that's the case, then the measure of angle C would be 7.93 degrees. Okay, so that leaves us with finding out what C is in each of the cases. Okay, so let's go back to, let's split this. And in case 1 here, so the second part of this problem, so we got the second part of this problem, and then we've got a first part and second part of this problem over here too. In each case, we're going to find out what C is. So going back to my first example, to find C, I'm going to use 4.8 over the sine of 28 is equal to C over the sine of 116.07. And I solve that equation and I find out that C is approximately 9.18. Okay, so I have C there, so this would give me 9.18. And now I need to find C in the other case, so I'm going to use basically the same setup as in my previous example, 4.8 over the sine of 28. But this time I'm going to use C over the sine of that 7.93. And when I do that, I find out that C is approximately 1.41. Okay, so this is a side-side angle case in which we have two possibilities, and there are the two possible triangle solutions we have. Okay. All right, we have one more application problem dealing with the side-side angle case. So we're going to look at this one. In this case, two surveyors are standing at points A and B. So we have points A and B here. And they're measuring a building. The surveyor at point A is 20 feet further away from the building than the surveyor at point B. So basically what that means is that the distance between these two is going to be 20. The angle of elevation of the top of the building from point A is 58 degrees. So we have the measure of this angle here is 58 degrees. And the measure of the angle of elevation from the top of the building to point B is 72 degrees. And what we're looking to do is find out how tall the building is. All right, so here's our 72-degree angle here. and we're looking to find out what h is there, the height of the building. Um, so really what you're given is two separate triangles here. And given those two separate triangles, we definitely need more information um, in this triangle here, because you notice in this triangle we're only given basically one measurement, and that's this 72-degree angle here. So what I'm going to do is this side here is labeled A. If we had that information, that would make the hypotenuse there of a right triangle, and that would be very helpful. Now that side A is also part of a second triangle here, which would be here in green, that we're given a little more information on. So what we're going to do is use the information here. We have actually quite a bit of information about that green triangle. So I'm going to sketch that green triangle, and we are going to use that to find the length, or find out the value of A. So let's give ourselves some more space. Okay, here we go. So we'll start out sketching that green triangle that I have there. Looks something like this. And in that triangle, I know this is 72 degrees, and it makes it's a linear pair using this angle. So if that's 72 degrees, and that makes this angle here 108 degrees. Okay, we already know that the measure of this angle is 58 degrees. And we know the length of this side here is 20. That's the distance between the two people standing there. So if we have an angle measure of 108 degrees, a 58-degree angle, that's enough information to figure out using that this is 14 degrees. And now remember that we said we were going to try to find out what A is, because that's also a part of that second triangle that we're going to end up working with. So the second triangle being where we're trying to find the height. And what we're trying to do is find A. So A, this is A. Okay, so let's go ahead and find A. Just choose a pair that we have. We have a side that is 20, and opposite that is an angle, a 14-degree angle. So we're going to use 20 over the sine of 14 to get us started. And we want to find A. So we're going to say A over the sine of 58. I'm sorry. No, we're not going to do that. Yes, that's right. Sorry. All right, sine of 58. Because these two are opposite each other. Okay, so once we have that, then we just go ahead and solve for A. We find out A is approximately 70.12. Okay, so once I have A is approximately 70.12, I come back over and I label this as 70.12, which I found. I have a 90-degree angle. I have this angle measures 72 degrees because it was given to me. And now we're in a situation where we can just use our trig ratios. I have an angle measure. I would like to find the opposite, and I'm given the hypotenuse. So that means that we can set up the equation sine 72 is equal to opposite over my hypotenuse. And that's going to give me that h is approximately 66.69 feet. Okay. And there we have it. There's one other thing in this section that we're going to talk about, and that's just using area formulas to find areas of triangles. It's a basic formula, and so I'm going to introduce you to that formula, give you a problem, and then let you do a little work on that. Okay, so okay, here's our formula. Okay, so the area of a triangle with sides A, B, and C is the square root of the product S times S minus A times S minus B times S minus C. So you know what A, B, and C are, but what you don't know is what S is. So S is going to be equal to half the perimeter of that triangle. Okay, here we have it. So there's our formula. And now I'm going to give you a problem to do with that. What I would like for you to do is find the area of a triangle with side lengths 8, 10, and 14. Okay, so you're just going to use your formula to find that and bring it to class. We'll go over that as well as a proof for the law of sides. And that concludes section 10.2.